In the quiet solitude of our night, we look up. We see a tapestry woven with singular points of light. Our celestial mechanics are governed by a comforting solitude. One sun to warm our days, one moon to haunt our dreams. This simple, predictable ballet has defined our existence. It has shaped our myths, our religions, our science. But this cosmic loneliness, this predictable rhythm, is not a universal truth. It is merely our local circumstance. Across the unfathomable gulfs of interstellar space, there are other skies, other dawns, other realities. Imagine a world where the morning arrives not once, but twice, a sky pierced by two suns painting the landscape in alien hues. One, a brilliant, fiery giant, and its smaller, hotter companion. They chase each other across the celestial sphere, a perpetual dance of gravity and light. Seasons here would not be a simple progression of heat and cold. They would be an intricate, chaotic symphony of overlapping summers and fleeting, unpredictable winters. For decades, such vistas were the exclusive domain of science fiction. They were dreams painted on the canvas of cinematic fantasy. Yet our telescopes, our tireless eyes on the cosmos, have revealed that this dream is a widespread reality. Nearly half the stars in our galaxy are not solitary wanderers like our Sun. They are bound in pairs, triplets, or even larger stellar families. And this simple fact presents a profound and troubling paradox. It poses a question that has haunted astrophysicists for a generation. In the violent gravitational blender of a two-star system, how could a planet possibly be born? The standard narrative of planetary creation is one of relative calm. It begins with a single newborn star surrounded by a vast spinning disk. A protoplanetary disk, a cosmic nursery of gas and dust. Think of it as a river of celestial material flowing gently in a circle. Within this placid current, tiny grains of dust begin to stick together. Electrostatic forces like a faint cosmic static cling bind them. They grow from dust bunnies into pebbles, from pebbles into boulders. These larger bodies, called planetesimals, now have enough mass to exert a gravitational influence of their own. They become the seeds of worlds sweeping through their orbital paths, accumulating more and more material, growing ever larger. Over millions of years, this gentle, patient process builds the majestic planets we see in our own solar system. Now introduce a second star into this delicate nursery. The picture shatters into one of unmitigated violence. Our gentle circular river becomes a raging, unpredictable maelstrom. The gravitational pull of the second sun acts like a monstrous paddle, violently stirring and disrupting the disk. It carves vast, empty chasms in the river of dust. It whips up material into chaotic, high-speed collisions. Instead of gently sticking together, colliding particles would obliterate one another. Any fledgling planetesimal, any hopeful seed of a world would be flung out into the cold darkness of interstellar space. The gravitational tides of the two stars would be a relentless engine of destruction. In this cosmic demolition derby, building a planet should be as impossible as building a house of cards in a hurricane. For years, this was the prevailing wisdom. Binary star systems were considered barren. They were beautiful, dynamic, but ultimately sterile. And then we found TOI 2267, a system that spits in the face of our understanding, a system that should not exist. Some 650 light-years away, in the constellation of Triangulum Australe, lies a pair of suns locked in a tight 32-day orbit. One star is much like our own, a stable G-type yellow dwarf. Its companion is a smaller, cooler, but still formidable M-type red dwarf. They circle a common center of gravity, a waltz of celestial fire, and around this impossible, chaotic duo we found not one world but three planets dancing to the rhythm of two suns. They are gas giants larger than Neptune, smaller than Jupiter. They orbit their parent stars in a stunningly compact and orderly formation. Their existence is an affront to our models, a beautiful, magnificent anomaly that demands an explanation. These are the triple worlds of TOI 2267, and their story forces us to rewrite the very book of creation. To grasp the magnitude of this cosmic puzzle, we must first journey back in time to when our view of the heavens was simpler. For millennia, humanity saw the stars as fixed singular points. They were divine lights, unchanging and eternal wholes in a celestial sphere. The concept of a star having a companion was utterly alien. It was the telescope that shattered this ancient illusion. In the 17th century, Italian astronomer Giovanni Battista Riccioli pointed his primitive instrument at Mizar, a star in the Big Dipper's handle. Where the naked eye saw one point of light, his lens revealed two. Two distinct stars gleaming side by side. This was the first confirmed binary star, a shocking revelation. It suggested the heavens were more complex, more dynamic than the serene perfection envisioned by the ancients. But for centuries, these were mere curiosities. No one dared to imagine that worlds could circle such strange pairs. That notion was too radical, too defiant of the perceived gravitational order. The search for planets beyond our own, for exoplanets, began in earnest only in the late 20th century. Early methods were crude, relying on detecting the subtle wobble a large planet induces in its parent star. It was the transit method that revolutionized the field. The idea is simple in principle, but fiendishly difficult in practice. If a planet passes directly in front of its star from our point of view, it will block a tiny fraction of the starlight. This causes a minuscule periodic dip in the star's brightness. Imagine watching a distant lighthouse from across a vast ocean. If a single small bird flies between you and the light, the beam will dim for a fleeting moment. By measuring the depth and regularity of that dimming, you can deduce the size of the bird and how often it circles the lighthouse. Our planet-hunting telescopes like Kepler and its successor TESS are designed to be the most patient lighthouse watchers in history. They stare unblinkingly at hundreds of thousands of stars, searching for these telltale shadows, these fleeting cosmic winks. When the TESS satellite first observed TOI 2267, the data it sent back was a confusing, almost unreadable mess. The light curve, the graph of the system's brightness over time, was not a clean series of dips. It was a complex jumble of signals, a chaotic scribble of light. This is because observing a binary system is like watching two lighthouses at once. They orbit each other, eclipse each other, and their combined light fluctuates. Trying to spot the shadow of a tiny planet against this dazzling dynamic background is an astronomical nightmare. It took a global effort, a symphony of ground-based observatories from Chile to South Africa, to untangle the knotted threads of light. Scientists had to first model the intricate dance of the two stars perfectly. Only then could they subtract that complex light signature from the data. And in the quiet that remained, they heard it. 3 faint rhythmic heartbeats, 3 distinct repeating transit signals. The undeniable evidence of 3 planets where none were thought possible. The worlds of TOI 2267 are locked in what is known as a resonant chain. For every one orbit, the outermost planet completes. The middle planet completes roughly 2. For every 2 orbits, the middle planet completes the innermost planet, completes roughly 3. This is not a random arrangement. It's a state of profound gravitational harmony, a delicate clockwork precision that suggests a peaceful and orderly past. This discovery deepened the mystery to an almost unbearable degree. Not only do these planets exist in a chaotic environment, but they exhibit an architecture of sublime order. How could such a finely tuned celestial instrument be assembled in the middle of a gravitational tempest? The old models of planet formation were not just inadequate, they were utterly broken. A new theory was needed, a radical reimagining of how worlds are born. The solution to this impossible riddle lies in a simple, elegant twist. It required astronomers to think not about where the planets are now, but where they might have been born. The key insight was to challenge the assumption that the protoplanetary disk must be aligned with the orbit of the 2 central stars. Let's construct an analogy to visualize this paradigm shift. Imagine a potter's wheel spinning perfectly flat and level. This is our traditional model of a protoplanetary disk around a single star. The clay at the center represents the star, and the clay spreading outwards is the disk from which planets will form. A skilled potter can use this stable, predictable rotation to shape a beautiful, symmetrical pot, our orderly solar system. Now let's represent the binary star system. Place 2 powerful aggressive magnets under the potter's wheel, offset from the center and spinning on their own axis. These magnets represent the 2 stars, their gravity pulling and twisting everything. As the wheel turns, the magnets would wreak havoc on the clay. They would tear it apart, fling it from the wheel, and prevent any stable shape from forming. This is the old problem, the hurricane that prevents planetary creation. It seems hopeless. No pot can be made on such a violent wheel. But what if the potter did something clever? What if instead of placing the clay flat on the wheel, they tilted the entire wheel at a significant angle? This is the concept of a polar or misaligned circumbinary disk. In this tilted configuration, something magical happens. The chaotic destructive forces of the two spinning magnets are no longer pulling the clay apart in the same plane. Instead, their gravitational torques average out over time. The intense tug of war that previously destroyed everything now creates a strange kind of stability. The tilted disk experiences a more uniform, less disruptive gravitational field. The clay is no longer being ripped from side to side. It is being guided gently by the averaged-out influence of the central stars. A calm harbor has been created in the midst of the storm. Within this tilted, stable disk, this polar disk, the gentle, patient process of planet formation can finally begin. The cosmic dust can stick together. The planetesimals can grow undisturbed. The resonant chain of the three planets could form in this peaceful nursery far from the gravitational chaos of the central stars. So the planets of TOI 2267 were not born in the inferno. They were forged in a calm, sheltered environment, a cosmic womb protected by the strange geometry of a tilted disk. They grew together, locking into their resonant harmony like a set of celestial gears, meshing perfectly into place. But this only solves the first part of the puzzle. The planets we see today are orbiting incredibly close to their parent stars, deep within the zone that should be chaotic. Their birthplace was a distant, calm harbor. Their current home is in the heart of the tempest. How did they get there? The answer lies in a grand, stately procession known as planetary migration. After the planets formed in the outer tilted disk, they were still embedded in a vast sea of leftover gas and dust. The planets, now massive bodies, exerted their own gravity on this material. This interaction created intricate spiral waves in the disk, like the wake of a great ship moving through water. These waves in turn exerted a gravitational drag on the planets. It was a cosmic conversation, a slow dance of push and pull. The net result of this dance was that the planets lost orbital energy. They began a slow, inexorable spiral inwards towards the central stars. Because they had already formed in a resonant chain, they migrated together as a single gravitationally linked convoy. They maintained their beautiful clockwork harmony as they moved. They journeyed from the calm, protected nursery of their birth into the dangerous, chaotic inner sanctum of the binary system. By the time they arrived in their present-day orbits, they were fully formed massive worlds. They were gravitationally robust enough to withstand the buffeting forces of their two parent suns. They were not built in the hurricane. They were forged in tranquility and then sailed directly into its eye, emerging intact. This theory, the polar formation and migration model, is a breathtaking piece of cosmic detective work. It elegantly explains every bizarre feature of the TOI 2267 system, the existence of the planets, their tight orbits, their perfect resonance. It transforms an impossible anomaly into a beautiful testament to the universe's ingenuity. It tells us that nature is more clever, more resourceful than our initial simplistic models ever allowed, and the implications of this discovery are staggering. They ripple outwards, touching every corner of astrophysics. Suddenly, the nearly half of all star systems that are binaries are not barren wastelands anymore. They are potential planetary habitats. The number of worlds in our galaxy, the number of potential homes for life may have just doubled. We are forced to re-evaluate what we consider a normal solar system. Perhaps our own quiet single-star neighborhood is the real oddity. Perhaps the galaxy is teeming with worlds that know the light of two suns. This opens a floodgate for the imagination, but it is an imagination now grounded in scientific reality. What would it be like to stand on a moon orbiting one of these triple worlds? The sky would be a celestial masterpiece of constant motion. The two suns would rise and set at different times, creating complex overlapping days and a near-perpetual twilight. Shadows would be a strange and fluid thing, sometimes single, sometimes double, stretching and contracting as the two light sources danced across the heavens. The seasons would be a dizzying, intricate cycle, driven not just by axial tilt, but by the 32-day orbit of the stars themselves. Periods of intense dual-sun heat could be followed by the cooler reign of a single star, or the brief true darkness, when both suns dip below the horizon at once. The mythology of any life that evolved there would be profoundly different from our own. Their gods might be twins, one of light, one of shadow, forever chasing each other. Their calendars would be a marvel of complexity, tracking the cycles of 3 planets and 2 suns. Their fundamental understanding of reality would be rooted in duality and partnership, in the interplay of 2 cosmic forces. The discovery of TOI 2267 is not an end, it is a beginning. It is a signpost pointing us towards a new, richer understanding of the cosmos. It tells us that we must be prepared to have our most fundamental assumptions challenged. We now have a new blueprint for where to look for planets. Future observatories like the James Webb Space Telescope can now be aimed at these binary systems with renewed purpose. Webb's powerful infrared eyes could potentially probe the atmospheres of worlds like those in the TOI 2267 system. Could we detect the chemical fingerprints of water, of methane, of oxygen? Could these strange dual-sun worlds harbor the building blocks of life? The question is no longer if planets can exist there, but what are they like? And what other bizarre and wonderful planetary architectures are waiting to be discovered? Are there planets that orbit in figure-8 patterns around their 2 stars? Are there worlds that are passed back and forth between stellar companions? The universe has demonstrated a capacity for creativity that far exceeds our own. We began this journey with a simple sky, our sky, a place of singular, dependable constants. We saw the discovery of a second star in a familiar point of light as a curiosity, a celestial oddity. Then we built machines that could see the invisible, and those machines showed us an impossible system, a cosmic paradox that threatened to unravel our theories of creation. But from that paradox, a deeper and more beautiful truth emerged. A story of a tilted, protective nursery, of a grand inward procession of worlds born in peace and delivered into chaos strong enough to survive. TOI 2267 is more than a catalogue number. It is a lesson in cosmic humility. It reminds us that our models are only sketches and the universe itself is the final, unassailable masterpiece. For every mystery we solve, a dozen new, more profound questions arise. And so our quest continues. We look up at our own quiet, lonely sky with a new sense of wonder, not just for what is there, but for all the magnificent possibilities that are not. And we know with more certainty than ever before that somewhere out there a double dawn is breaking. A new day is beginning, painted in the light of 2 suns, and we are one step closer to understanding how it came to be.